Welcome to Mindcast, the podcast where we dive deep into fascinating stories and uncover hidden insights. I'm your host, Will, and today we're embarking on an incredible journey into the heart of one of World War II's most legendary machines, the Enigma. Now, when you think of the Enigma, your mind probably jumps straight to Bletchley Park, Alan Turing, and the incredible Allied efforts to break its codes. And rightly so. That's a truly monumental achievement. But today, we're going to flip that narrative on its head and explore a less told, yet equally crucial aspect of the Enigma story. We're going to ask a provocative question. How often did the Enigma break itself? We'll explore how the very complexity that made the Enigma so formidable also became its greatest operational weakness, leading to a significant, often overlooked, rate of internal communication failure for the German forces. Get ready to have your perspective on this iconic machine completely transformed. Now, the conventional story of the Enigma machine during World War II is absolutely captivating, isn't it? We often hear all about the brilliant minds at Bletchley Park and how they ultimately cracked the German ciphers. The central question in that narrative is always, how was Enigma broken? And it's a fantastic story of Allied triumph and ingenuity. But today, we're flipping that script entirely. We're asking a different, yet equally critical question: how often did the Enigma break itself? You see, while the German High Command was supremely confident in the machine's security, believing it unbreakable, this very complexity was also its greatest operational weakness. It created a system profoundly unforgiving of human error. This meant that often messages were rendered completely indecipherable, not by Allied codebreakers, but by their intended German recipients. This wasn't just an opportunity for the Allies, it was a persistent source of self-inflicted communications fratricide.
The German High Command's strategic miscalculation, prioritizing technological security over human factors, directly fostered an environment where internal communication failure could flourish. It's a truly fascinating paradox, and we're just getting started. Okay, so how did this supposedly unbreakable machine actually work? Well, it was a truly ingenious, yet incredibly delicate electro-mechanical device. Think of it as a symphony, where every single instrument and player had to be perfectly in tune, hitting every note flawlessly, or the whole performance fell apart. At its heart, the Enigma had a keyboard, just like a typewriter. But when you pressed a key, the electrical signal took an incredible journey. First, it went through the plug board, or Steckerbrett, right there at the front. This board allowed operators to swap pairs of letters, creating reciprocal connections. So if A swapped with B, then B also swapped with A. This alone added immense cryptographic complexity. Then, the signal moved through 3 rotating rotors, the true heart of the machine. Each rotor had a unique internal wiring that scrambled the letter, before hitting the reflector, which bounced the signal back through the rotors again, but on a different path, before going back through the plug board and finally lighting up a lamp showing the encrypted letter.
And here's the kicker. With every single key press, the rightmost rotor would advance, kind of like an odometer. And at specific points, it would make the middle rotor turn, and eventually the leftmost rotor. This constant movement meant pressing the same key twice would give you 2 different encrypted letters, creating a truly dynamic cipher. But for any of this to work, the sender and receiver had to have their machines configured exactly the same way. This was managed through daily key sheets. Every single morning, operators had to carefully select the correct rotors, put them in the precise order, set the ring settings on each rotor, and then connect 10 specific cables on that plug board. Then, for each individual message, they'd set their rotors to a daily base position, invent a random 3-letter message key, encrypt that key, and in early, flawed procedures, they'd encrypt it twice and transmit it. Only then would they reset their rotors to their chosen message key and begin encrypting the actual message. If even one tiny detail was off, from selecting the wrong rotor to misplacing a single plug board cable, the entire message would be meaningless to the recipient. It truly demanded perfection. So we've talked about the Enigma's incredible complexity, but what about the people actually operating these machines? This brings us to the crucial human component, the Funker or radio operator from the Wehrmacht's Signal Corps. These weren't cryptographers. They were trained specialists, yes, but their job was to follow a rigid multi-step procedure under unimaginable pressure. Imagine them in the cramped, noisy confines of a tank or a freezing, muddy field post, exhausted and under fire. The Enigma system, in its brilliant design, actually offloaded a critical cryptographic function, the generation of a random message key, to these human operators. And let's be honest, humans are notoriously bad at true randomness, especially when stressed.
This reliance on fallible human beings created endless opportunities for error, and we can broadly split these failures into two fascinating categories. First, we have Category 1 errors, the predictable patterns that ironically helped the Allies. Bletchley Park famously exploited these mistakes, like the early, flawed procedure where the three-letter message key was encrypted twice. This provided a mathematical foothold for the code breakers.
Or think about the sillies, those predictable, non-random message keys operators often chose, like AAA or QWE. These drastically reduced the search space for the daily key, giving the Allies a huge advantage. These consistent blunders were a clear sign of poor discipline and operator carelessness. But then there's Category 2, and this is where our story gets even more intriguing. Errors that led to unrecoverable chaos, making messages unreadable to the intended German recipients themselves. Now, let's dive into that second category of errors, the ones that often went completely unnoticed by the Allies, but were absolutely devastating for the Germans themselves. Category 2 errors, or unrecoverable chaos. This is where a secure communication turned into nothing but useless noise for the intended German recipient, effectively breaking the link from within. Imagine the painstaking process of setting up an Enigma. If an operator made a mechanical misconfiguration, like grabbing rotor 4 instead of 5, or putting the correct rotors in the wrong left-to-right order, the entire machine would fundamentally scramble messages differently. The result? Pure, unadulterated gibberish on the receiving end. Or what about the ring settings? Just a tiny slip of the finger setting a ring to F instead of G meant the sender's rotors would turn over at different points than the receiver's. You might get the first few letters, but as soon as that first rotor turnover occurred, the machines would be out of sync and the rest of the message would instantly devolve into chaos. And the plug board? A single cable in the wrong socket, or even accidentally swapping the ends of one cable, would completely alter the reciprocal letter swapping, rendering the entire message indecipherable to a correctly configured machine. It wasn't just mechanical errors either. Procedural misconfigurations, like the sending or receiving operator typing the wrong three-letter message key when manually setting their rotors, would send the entire message into a black hole of nonsense.
Even simple transmission errors in Morse code, especially if they hit the critical encrypted indicator group, meant the recipient would derive the wrong message key and be completely unable to decrypt the main message body. The crucial point here is the Enigma's brittleness. It lacked any form of error detection or correction, unlike modern communication systems. A sender making a plugboard error would have no idea anything was wrong. The machine would dutifully churn out what looked like valid ciphertext, but for the receiver, it wasn't a few incorrect letters, it was a completely random, unintelligible string. Their only recourse was to request a full retransmission, wasting precious time and bandwidth, and unfortunately, alerting the Allies to their communication attempts. A single point of failure almost invariably resulted in total, unrecoverable message loss. So what did this brittleness and unrecoverable chaos mean in the heat of battle? Let's paint a picture of the real-world consequences with a plausible scenario. Imagine it's the bitter winter of 1942 on the Eastern Front. A Funker, a radio operator in a forward panzer reconnaissance unit, is shivering, exhausted, and working by the dim, flickering light inside his cramped vehicle. He's just spotted a major buildup of Soviet armor, vital intelligence. While performing the daily setup of his Enigma, His fingers, numb with cold, fumbled on the plug board. He accidentally plugs one end of a cable into the D socket instead of the F socket. Unaware of his tiny yet catastrophic error, he proceeds. He correctly chooses his message key, encrypts the indicator, and urgently transmits his report. Miles away, at divisional headquarters, the receiving operator correctly sets up their machine, perfectly attuned to the daily key sheet. They receive the Morse code transmission flawlessly and type in the indicator, revealing what they believe to be the sender's chosen message key. They set their rotors to this key and begin typing the incoming ciphertext. But instead of a coherent report on enemy tank formations, the lampboard produces an unintelligible string of random letters. The vital intelligence is lost. There's no way for the receiver to know if the error was their own, the sender's, or momentary blip in transmission. Their only option is to radio back requesting a full retransmission, a time-consuming process that consumes scarce radio bandwidth and, crucially, alerts listening enemies to their communications. That tactical opportunity to preempt the Soviet attack? It vanishes, not because of Allied code breaking, but due to a simple, uncorrectable slip of a single plug.
Now, while the German military didn't exactly keep meticulous records of Enigma misconfiguration rates that conveniently survived the war, a compelling case for their frequent and detrimental occurrence can be built. We might not have spreadsheets, but we have strong evidence.
Consider the physical evidence unearthed from surprising places. Message forms recovered from the sunken submarine U-534, for instance, offer a fascinating glimpse into a communication environment absolutely plagued by error. These artifacts show numerous mistakes in the handwritten ciphertext, often caused by poor Morse code reception, like an L being mistaken for an R. In one striking case, a complete four-letter group was simply missing from a copy of a message. This clearly demonstrates that even before we get to the immense complexities of Enigma configuration, the basic channel of communication was already unreliable, a condition that would only magnify the impact of any Enigma setup error.
Then there's the procedural evidence. The very existence of formal procedures within German radio doctrine for requesting retransmissions is a silent, implicit acknowledgement that message failure was not just an occasional hiccup, but a common and anticipated problem. Furthermore, a highly insightful post-war analysis by General Albert Prawn, a former high-ranking signals officer, explicitly notes that the inadequate training of replacement operators during the war led to mistakes and breaches of discipline. This isn't just speculation, it's a confirmation from within the Wehrmacht that operator-level unreliability was a known issue.
And finally, the most compelling argument of all, logical and inferential evidence. We know, beyond a shadow of a doubt, that German operators were consistently making predictable, lazy errors, what Bletchley Park called sillies. They were choosing non-random, easy-to-guess message keys. It is simply illogical to assume that these very same operators, who frequently failed at the relatively simple task of choosing a random three-letter sequence, were simultaneously achieving absolute perfection in the far more complex, multi-stage manual setup of the machine. The same human factors, the fatigue, the stress, the boredom, the poor training, the harsh conditions that led to predictable sillies would inevitably have also led to random, catastrophic misconfigurations. The proven existence of one category of error is, in fact, the strongest possible indicator for the existence of the other. It's almost a certainty. So, what was the bigger picture here? The cumulative effect of these individual message failures, this constant low-level communications friction, extended far beyond just tactical inconvenience. It created a persistent drag on German operational tempo and strategic cohesion. This self-inflicted weakness was profoundly compounded by a high-level command culture that was, frankly, institutionally blind to the Enigma's practical flaws. Think about German military doctrine, especially blitzkrieg, that lightning war strategy. It was revolutionary, built entirely on speed, maneuver, and the incredibly close coordination of combined arms, like panzer divisions and Luftwaffe air support. This doctrine wasn't just about having tanks and planes, it was about their synergistic application, which depended completely on rapid, reliable, and flexible communications. Every single Enigma message lost or delayed due to a Category 2 misconfiguration directly introduced friction and uncertainty into this finely tuned system. A delayed reconnaissance report meant a panzer division could roll right into an ambush.
An unreceived request for air support left armored spearheads vulnerable. This constant internal communication breakdown acted as an underlying handicap, eroding the efficiency of the German war machine.
And how did the High Command respond? Their faith in Enigma's security was absolute, almost unshakable. When Allied actions strongly suggested their communications were compromised, German investigations consistently exonerated the Enigma machine. Instead of looking inward at their own operational procedures, they blamed superior Allied radar, espionage, or even the supposed poor operational security of their Italian allies. This mindset prevented any serious, systemic review of their own Enigma protocols, creating a dangerous confirmation bias that ultimately cost them dearly. And so, the full story of Enigma's failure reveals a fascinating paradox, all rooted in a single, powerful cause: human error. The machine's incredibly complex design, meant to be its strength, ultimately failed in two distinct yet parallel ways. First, we have those predictable, sometimes lazy mistakes, what we called Category 1 errors. These created that external vulnerability that Bletchley Park so brilliantly exploited, giving the Allies a decisive strategic advantage. But then there were the Category 2 errors, the random, chaotic misconfigurations that resulted in a constant stream of failed messages. These messages weren't decrypted by the enemy, they simply became useless noise, silently degrading German operational effectiveness from within. Both types of failures were happening simultaneously, caused by the very same operators, working under the same brutal conditions, and ultimately overlooked by the same overconfident high command. It's a powerful lesson. The Germans built a lock they believed was unpickable, yet their own personnel frequently fumbled the key, sometimes dropping it for the enemy, and other times failing to get it into the lock at all. It truly shows that even a theoretically unbreakable machine is only as strong and reliable as the human hands that operate it.